A programmable DC power supply is one of the most important things you'll have in the lab. This is the DP832 from Riggle Technology, and we'll talk about how to get it set up today. First things first, this is how you plug it in. It comes with an adapter you've probably seen on things like a printer, and a little switch up here if you are using 230 or a different voltage than what we're using, 120. You also see USB and digital input devices. We won't be talking about those today, but very important part of how cool this technology is. You also see the back of the fan. This is a multi-100-watt power supply, so there's going to be some heat generated inside of there. If you're setting this up, you want to make sure that you don't put anything directly behind the fan or on either side, just to let air flow through. So, plug it in and turn it on. As it boots up, you'll hear the fan start to kick in, and this is what the screen looks like. You see all 3 channels, and you can see right away what the voltage and current are set to and whether or not they're on. They will also light up here if you turn a channel on. If this is your first time, you might as well get used to some of the settings in here. We can go to the display button and change how the screen looks. Change things like brightness, contrast, I think those are fine, how much of each color RGB is available, and the theme and display mode. The theme is pretty straightforward. It's just, do you prefer to see green, blue, white, or red? We'll leave it at green, it's nice and easy to see. If you do go to this display mode, we're in normal right now. You saw what that looked like. Waveform is really interesting. It shows literally the waveform of what the voltage is doing. So now, if I turn on channel 1, you see channel 1 go high. You're also monitoring the other 2 channels. Turn it off, it goes low, and we won't cover this here, but because you have the USB output and some internal storage here, you can capture that waveform and later go in and zoom and see exactly what that transient looks like. The other display mode you can use besides normal and waveform is dial. That's just a little bit different look. They're literally dials rather than numbers that you can change, but you always change it with the dial. So we'll go back to regular. Because that's nice and easy to use. So these 3 channels all operate independently and they all have a ground there. It will come with several clips. So let's plug one channel in and just verify it with a multimeter to make sure that we are all on the same page. So I have it set to 18 volts right now. With a relatively low current limit. Even though this can go up to 3 amps, I have it set to 50 milliamps. So in case I wire something wrong and a lot of power is going to go somewhere, it's only 50 milliamps. So it's off. We turn it on. We see 18 volts. Perfect. We can check how high a current will go with something as simple as a little resistor. Now, like I said, this will output 3 amps, so let's crank it up. To change the voltage or current, I have voltage selected right here. You see it's bright. You can swap to current by clicking that button. Over voltage protection and over current protection are both off, although the device will still limit itself. It won't completely shut off when it hits those. So current, I have it all the way over in milliamps right now. I could move to tens of milliamps to change that number with the dial. Hundreds of milliamps, and we're going to go all the way over to amps. You can also just use the buttons around the edges to enter it. So we could say 3 amps, okay. So 18 volts, 3 amps, that's quite a bit of current. But because it's a resistor, it's not going to get to 3 amps, which is fantastic. It's limited at about 90 milliamps, which is exactly what we wanted. If we used a much smaller resistor, that could actually catch fire, so be careful when you're doing that. So one may ask, why would you ever need more than one output on a power supply? It's great for things like testing the brightness of LEDs to match things up while you can easily dial in the current and voltage of both channels or 3. In this case, we'll just use 2. and I'm going to hook up 2 LEDs of different colors. Typically, when you're hooking up LEDs, you try to put them at a voltage that is typical to your project, probably 5 volts for an Arduino or something, and you use a resistor to limit the current. However, you don't always know how much to limit the current, right? You don't exactly know what the perfect brightness is going to be because they all have different voltages, and even when you're doing the math, you're kind of approximating. This is a really great, clean way to tune to the voltage you want, but because you can also limit the current, you can see exactly how much current should be going through it at that voltage to get the brightness you want. So this is still set to 18 volts, so I would explode this if I turned it on. We will go back over to voltage and say, let's do 3 volts. 3. We will also turn the current down from 3 amps because that would also explode this. Current, let's start low. Let's start 20 milliamps, which is 0.02 amps. Great. We'll set channel 2 by going to 2 to the same thing, 3 volts, which it's already set to, and current. This time we'll do it with the little wheel, go up to 20. So now, when I turn the first channel on, we see the light come on. And when I turn the second channel on, that light also comes on. And this right here is what I'm talking about. The green one is much brighter than the yellow one, and they're at the exact same power. So if you were trying to do something in a display, that would be pretty disproportionate. So let's find out how much we need to lower this one to get it to about the same brightness. I'll hold them close because it has protection in case I accidentally short them. So I'm already keyed into the green LED's current at the lowest possible resolution. So I'm just going to start decreasing it, and you'll see that current drop along with the brightness of the LED. The resolution only goes down to tens of milliamps, so I can't actually take it any lower. I could adjust the voltage down, or I could start raising the current of the amber LED. So we'll go back over to channel 1. Voltage is still okay, we're at current, and we'll start raising it. And you see it get brighter. So now, if I was looking at these side by side, I would actually say the amber's a little bit too bright. So we'll tone that back down, take it to about 40 milliamps. And I would say those are pretty close. I don't know if that's going to show well on camera at all, but I would say they're pretty close. But look how big of a difference that is. If I'm operating off a 3-volt supply, I can't just say, I need both of them to be at a certain voltage and we'll put a 100 ohm resistor in there. We really do need to dial it down so that the green is operating at maybe 5 milliamps and the amber is operating closer to 40. Big difference and very important for power considerations. So if you need all 3 outputs, fantastic. We have that. Rigol also has all kinds of things, single, double output, higher current outputs, higher voltages, whatever you need. Check out our new catalog.